This is lesson 42. I'm on page 287 on the bottom, and we're talking about volume. First thing you need to know in volume is when we're talking about volume, we're talking about three dimensions. So when we label something, it's centimeters cubed, 3 dimensions, or it's feet cubed. Before, when we were talking about flat surfaces and 2 dimensions, it would be centimeters squared and feet squared. But we're in 3 dimensions, that's why we are cubed. That's the first thing we need to know. So far, so good. Now I'm on page 288. The next thing we need to know is the volume of a prism. Volume equals the base, the bottom, times the height. This base is a capital B. Okay, if you look at that picture on 288, the base is 5 times 4. That's 20. The height is 3. 20 times 3, it's 6D blocks. Now look below that. It says the volume of a rectangular prism is length times width times height. All the length times width is the base. So we went length times width, and we bring down the height, length times width times height. So we have length times width times height, volume of a rectangular prism. So far, so good. That already takes us up to example 1. It says to calculate the heating and cooling requirements for a room, one factor architects considers the room's volume. A classroom is 30 feet long, 30 feet wide, and 10 feet high. That's how many cubic feet. Let's take the shortcut. We know that it's 30 feet by 30 feet by 10 feet. Multiply those together. We have 3 times 3 times 1 is 9. With 3 zeros, we have 9,000. And since we have 3 dimensions of feet, 1, 2, 3, we have to cube it. 9,000 feet squared. So far, so good. Let's go on to example 2. Example 2 says, a sculptor carved a 2-foot cube of ice into a swan. Beautiful. At 57 pounds per cubic foot, what did the 2-foot cube weigh before it was carved? Okay, so let's take our cube here, and we know it's 2 feet on the side. It's 2 feet this way, and it's 2 feet this way, and it's 2 feet this way. 2 times 2 times 2 is 8, so it's 8 feet cubed. And since it weighs 57 pounds a cubic foot, we just go 57 times 8. 8 times 7, 56, put down the 6, carry the 5. 8 times 5, 40 plus 5, 45, 456 pounds. So far, so good. That takes us to example number 3. This one I love, but it's hard. So if you have any problems with any of these, it'll probably be this one. Now we're not going to put the numbers in right away because I just want you to think through this problem. What they want to know is in this odd shape, okay? How would you figure out the volume of this? And here's the clue, and Megan picked up on this, and Evan was right there picking up on this, is that what we want to do is think in terms of this 2-dimensional shape. So we're going to take that 2-dimensional shape and we're going to lay it out. We know how to do this. Just take a 2-dimensional shape, just chunk it. Okay. And figured out this, and figured out this. And what we found out was this is 540 feet squared. Squared because it's a flat 2-dimensional shape. And this was 144 feet squared. Squared because it's a flat 2-dimensional shape. Add those up, we come up with 684. And then all you have to do is multiply that by the height, which is 10. So now we have 6,840 feet cubed. So if you have one of these, and these are the hardest ones that you're going to see, it would be harder to try to chunk a whole three-dimensional piece than it would to just think in terms of what is the top, and then when you figure that out, multiply it by the height. Okay? So far so good, I hope. I can help you with those if you get stuck on those. This piece does not want to, there we go. I hope you like this. This is fun to do, but I'm sure I'll be working out a lot of bugs as I go along here. Okay. That takes us to example number 4. Find the volume of this cube. Okay, so let's take this cube up here. All they tell you is that this is 10. Well, if this is 10, you know that this width must be 10, and if the length and the width are 10, the height must be 10. And these are in terms of centimeters. So we just take 10 centimeters times 10 centimeters times 10 centimeters. 1 times 1 times 1 is 1. 3 zeros. 1,000 centimeters. Wait for it. Cubed. We're in 3 dimensions. Okay. Guys, this is so much fun. All right, that brings us to the practice set. If, when you're working on your homework, you get stuck and you need some more reinforcement, we'll go back to the practice set because the practice set introduces the main concepts for this volume. So let's take a look at A. In the practice set, it says, what is the volume of a tissue box with the dimensions shown? So their box kind of looks like this. And we'll copy this and paste it. And just connect the corners. Okay. So if we're looking at this box, they said that this is 9. And this is 5 with a width. And this is in terms of inches right now. And this is 4 for height. Length times width times height. I look at 5 times 4 is 20, and I look at 2 times 9 is 18, plus the 0 is 180, so we are 180 inches, wait for it, 3 dimensions, inches cubed. Okay? That's A in your practice set. B in your practice set. What is the volume of a cube with sides 2 inches long? All right, let's take a look at this cube right here. Each side is 2. This is 2. This is 2. And the height is 2. 2 times 2 times 2. That would be 8 inches cubed. Now we're going to look at a cube with each side 6 inches long. So we have 6 times 6 times 6. So this is 36 times 6. Put down the 6, carry the 3, 18, 216. This is 216 inches cubed. That brings us to D. How many times greater are the dimensions of the cube than in problem C than the cube in problem B? Well, the scale factor is 3 times bigger because each side here is 2, each side is 6. So we would say that the scale factor is 3 times. But is this 3 times bigger than this? No, because if we took 216, divided it by 8, that's 27. So it's 27 times bigger with a scale factor of 3. So why is that? And that's because we're operating in 3 dimensions. Since we're operating in 3 dimensions, we have to take a scale factor of 3 times a scale factor of 3 times a scale factor of 3. 3 times 3 is 9 times 3 is 27. That's how we come up with something 27 times bigger. sorry, the last one we're doing is letter E. It says, what's the volume of this block? And it says all angles are right angles. Or they should be right angles. So the difficult way to do this would be to try to chunk things in three-dimensional shapes. The easier way to do this, as we talked about earlier, was to take just the top in a flat representation, lay it out here, say, okay, what is that? Well, we know this is 8. We know this is 2. We know this is 3. So this must be 3 and 2. We know this is 8 and 8 and 2. So if we chunk these pieces, I'm going to say this piece up here is 8 times 2. So this must be 16. And if I look here, this piece is 8 times 2, 16. So if I added those up, I know that this piece is 32 centimeters squared. And now all we have to do is multiply by the height, which is 2. So we have 64 centimeters cubed. Okay, that's lesson 42. We went through the beginning, we did the practice sets, we did the examples 1, 2, 3, and 4, and you have the assignment 1 through 30. That's on 290 to 293. Good luck. Let me know if you need help, and then we'll check your assignments and see if you need any more help after that. Okay, good luck.